Mine Safety and Health Administration has produced this video to better inform mine operators, diesel equipment manufacturers, and support facilities concerning various aspects of the diesel regulations. Mining operations utilize a variety of mining machinery on mine property. The specific design may vary as long as each piece of machinery meets the performance requirements of the regulations. A fire risk analysis is recommended for all mining equipment used for underground mining. A fire suppression system must cover the engine, the transmission, the starter, hydraulic pumps and tanks, also fuel tanks, exposed brake units, air compressors, and battery areas. I'm Don Gibson with the Mine Safety and Health Administration. With me is Brian Booth of Booth Fire Protection.
Thank you, Don. The system we have on the board is a 6-nozzle system, which most of the inspectors are going to be running across. Because of the new diesel regulations, we had to go to a 6-nozzle system. Over here, Don, we have an Ansel 20-pound pneumatic. The pneumatic means that the cartridge is mounted right on the tank itself. This bush and disc union on the tank should be hand tight, snug only. You notice on the inside you got your bursting disc.
Okay.
This is what holds the chemical in until the system's ready to fire.
Now, isn't there a plastic ring?
Right here on the outside there's a plastic ring.
So it needs to be against this fitting?
Against this shoulder right here. Prevents it from falling out.
Okay.
Okay? These need to be changed on a semi-annual basis. These bush and disc unions need to be pulled out. They need to make sure that orifice is clean.
Is there any safety concerns that the industry and our industry inspectors need to be concerned about?
Yes, this cartridge, it's a CO2 cartridge, like we talked about. It's got 900 psi. For any one of the cartridges on these systems, you need to weigh them. They should be within a 1/4 ounce of their weight stamped on the cartridge. And it's usually stamped all around the top. Sometimes on the smaller ones it'll be stamped in the center. But there'll be a stamp weight on the cartridge. That weight includes the cap.
Also, Brian, this actuation canister must have this seal. Ansel's is blue.
Each one of these tanks on the labels tells you how much chemical goes into these tanks.
Poundage-wise.
Poundage-wise. Open up the top. A lot of times, because of the chemicals settling, because the vehicle's moving, settles down, should not be more than 3 inches below the top of that, the mouth of that canister.
The mouth being the opening up here?
Right.
Okay.
And the only time the siphon tube comes out is if you can physically see damage on a 6-year or on a hydro. You have to take it out for a hydro when you hydro test them.
Hydro being hydrostatic?
Hydrostatic testing, you have to take that siphon tube out.
Okay.
And there's a gasket that fits on a groove on the cap itself. This cap does not have to be gorillaed down. You can hand tighten the cap, and that's sufficient for this system. The point is that groove is designed in there, so if there's excess pressure in that tank, you start to remove it, it will relieve the pressure in there long before this cap comes off.
Okay. And we talked about the O-ring and the gasket on the bottom. This is what you were talking about?
Right.
Okay.
These need to be kept greased. On a semi-inspection, these caps should be pulled. The chemicals should be checked from the top as well as the bottom, and these rings should be greased.
Brian, we talked about the pneumatic tank. Let's talk about this tank. What's the differences between the two?
This tank here is a low-temperature tank. This is fired with nitrogen. It's also a 30-pound tank. This is the largest individual tank an Ansel you're going to find on the mine equipment. This is the cartridge that fires that one. Same configuration on the top as on the CO2 cartridge. There's no difference, except this carries 1,800 psi.
The bursting disc, again, is there a right and wrong way to put it in or install it?
Yes, you can't put it in backwards and it won't rupture.
And how would we know that, or how would the miners know that?
As you're looking at the bushing disc on the tank, you can see the X on the face of it.
This X?
That's the way it goes. It goes that way.
Brian, let's talk about the manual system and how it works and trace it through over to our canister.
This cartridge here is what will fire this pneumatic cylinder that will fire the nitrogen or CO2 bottle that fires the tank. So when the plunger is pushed, fires this cartridge, the nitrogen flows through here, through a check valve, into the top of the pneumatic actuator, driving a punching pin down that ruptures the disc in the top of the cartridge. After this system fires, you notice you've got a pressure relief valve on the system here. This will bleed off any excess pressure. If it doesn't, when the operator comes in, or whoever's going to recharge the system needs to come in, pull the ring on top of the pressure vent, bleed off any excess pressure in that system. Right. What happens at this point, you have the rush of either CO2 or nitrogen coming down through this hose, goes through the siphon tube, fluffs the chemical, ruptures the bursting disc, sends the chemical out to the distribution of piping. So the check valve splits the system up. So you could have 75 feet here, you could have 75 feet on this side.
75 feet on either
side, because your check valves, that's the maximum you've got there, because your check valves break that system up. There's an arrow placed on every check valve that's Ansel sends with their system. It shows the direction of flow. This, put in backwards, it will stop the system from activating. Automatic system, this particular unit is the SC control module. It's fired by a squib actuator, which is like a small explosive charge that fires, fills this area with a gas and drives that plunger down. Same type cartridge as what you've got over here on your remote actuator. This unit here is electric actuator or manual. You can use it either way. Okay? The module itself is a self-contained module, has a battery inside.
The new rule under 1911 requires a system status indicator. So that's what all this is all about.
Yes, if you notice on this, there's a green light flashing at this time on that module. That's saying that everything is okay, functional on this particular unit.
Okay, now what's the components that make that up?
Okay, the components that make this up, of course, the faceplate itself. We could remove this faceplate. Inside you will see the battery that runs this unit. It's a self-contained, so the battery is, this is the only power that it needs to operate this unit. If you have any problems with this detection on this system, if one of those wires comes loose, it'll give you an indication. It'll chirp at you, and it'll also flash the yellow light, telling you you've got a problem with the detection. Same with the release. If one of the wires comes off that squib lead, you'll get an indication and a chirping on this module.
The release is only for the squib lead?
That's what it says. That's release, detection, alarm, and battery. You've got different lights for all of them. Notice in the bottom here, this is a board where you've got your squib leads hooked in on the right-hand side. The other forward leads is your detection. This is what fires the system. If this is broken, burned, melted, is what together will trip this system and fire it.
Detection being automatic detection.
Right now, if you look on the board here, you can see the red wire running around. This red wire will run around the vehicle in the hazardous areas. It's designed to melt at 356 degrees. When this melts, it shorts out the wire, sends a signal to this board, which sends a signal to the squib, fires it, drives the pin down, and fires the system.
Okay.
This is a thermal detector, which is this device right here in the middle. You're going to have the same problem with this detector as you are with that. If you get a coat of anything on there, it's going to change the rating on that particular unit, whether it's a detector or whether it's a detection wire. If you get a coat of mud on it, you're going to change the rating on those. It's no longer going to be the same rating because of that mud or anything, paint or anything on those.
Brian, I understand that there's a new module out. Could you talk to us about that one?
Yes, it's this one down here, Don. It's the new SCN control module. Uses the same actuator as the old module does. The only difference is this module here has a buffer in it. They could actually take a reading off this on a laptop, read down what's been going on with the system on a laptop or a computer. Also, it's got a set of contacts in here to tie in the pressure switch for the shutdown. So you can tie the pressure switch right into here so that when the system goes off, it will give them the delay, the 15-second delay before the engine shuts down.
Brian, we've covered our out-by equipment. What's the module used on our permissible equipment?
Well, Don, you can see it in the center here. It's what they call an MP, which is mine permissible. This system module looks exactly like the old SC from the outside. Still got the same lights on it, gives you the same indications. The only thing different is that this got a gas-fired actuation system instead of squib-fired. It's got a gas cartridge When this fires off, a small electric charge will release that gas and drive the plunger down.
Brian, we've talked about our actuators, we've talked about our modules. Let's talk about the makeup of the system, the distribution lines, and the installation of the nozzles.
Okay. On the Ansel system, the supply line can either be 3/4 or 7/8. That's what they require for the Ansel specs. Secondary piping is 1/2-inch piping. All the only other size hose that you're using on an Ansel system would be for your nitrogen firing system, which is a 1/4 inch. So you can use 1/4, 1/2-inch, 3/4, or 7/8. Always supply lines, always 7/8 to 3/4, always. From the tank to your distribution T, which we have here, because this is a 6-nozzle system.
I understand that this street L cannot be used because it isn't listed or approved in any of the distribution systems.
From this point on, everything is 1/2-inch. Got different nozzles on the Ansel system. You can notice them down here, Don. The bottom one's down here. That's a C nozzle.
C nozzle. And what kind of pattern does it get?
That throws out a cone pattern. It'll throw out a pattern 6 feet out and open up to a diameter of 36 inches.
Okay. The next one?
Next one, that's a V-half nozzle. That V-half nozzle will throw a pattern out 36 inches each direction, opens up to 15 inches, and throws it out at 4 feet.
4 feet. And our third nozzle?
There's an F-half nozzle. That throws out a flat trajectory that will open up to 15 inches, but it's flat going out the sides, and it'll also go 32 inches each direction from the nozzle.
Brian, under our new rule, one of the requirements is that the system be sealed at the nozzles to prevent moisture, dirt, debris from entering the system. Now, as an installer, is there a maximum distance that the distribution T can be from the tank?
Yes. On this particular system, 30-pound system, 20-pound system, you can go 40 feet on the supply line. From the distribution to the nozzle is 18 feet. That's maximum. As you can see here, the hoses are pretty much the same length here. That doesn't necessarily, you don't have to necessarily be that way. This hose here, this group here, and that group there have to be within 3 to 1 of one another.
3 to 1. Now, what's that mean?
Okay, what that means is that the total length of these 3 hoses, we're just saying is 3 feet. The furthest one, or the maximum on the next group of hoses, could be only 9 feet. That gives you a 3 to 1 ratio there.
Okay.
But you have that limitations on these systems, which, if you notice, I put a curl in this particular hose. You can put wrap that hose to make up the difference to give you your 3 to 1. You notice that the fittings that we're using on here are all swivel fittings. There's an O-ring. They feel loose if you go up there and feel them. I know inspectors are going to go up there and they can grab those and they'll move.
Like this?
Right. And they're going to think, oh, there's a problem there. There's not. There's an O-ring built inside of this that'll seal that.
Okay.
That's why we use the swivels. We use the swivels for 2 reasons. One, for easy of installation. Second, easy to take it apart. If you break a hose, you don't have to dismantle the whole circuit to get that hose out. You can just take the one hose out.
All right. Well, good. Well, I appreciate you taking the time. Thank you.
Thank you, Don.